Number 11, which values are excluded from the domain of the rational function to the left? This is the same thing as vertical asymptote, which are conveniently given for you. There's your x values, there's the domain. So there's one at +2 and one at -2. So x does not equal -2, and x does not equal +2. And that's it. Number 12, evaluate log base 2 of 83 equals x. So evaluate means put in your calculator. There's nothing to solve. There's no reverse PEMDAS. There's nothing else to do. Just put it in your calculator, honestly. So just plug him in. Log base 2 of 83. And I get this 6.37504. Bam, done. 13. I want to solve this and see if there's an extraneous solution. If so, what is it? So remember when we did square root functions, they kind of look like this. It's going to be shifted to the left. So there's your square root function. And then I've got this linear function that kind of goes like that, roughly. And that's your actual solution right here. But then you got so that's a sideways parabola, right? So you've got this other portion that doesn't show up because it's not a function if that portion is there. But there would be another intersection right there. And that's your extraneous solution. So remember, an extraneous solution is a solution that might appear to be there, but it's really not a true solution. So most of you would want to do this by graphing. So I'm going to go ahead and put this in my calculator. Here's what that looks like. Actually, it intersects on the y-axis, which is not what I drew. Not to scale. Oops. So it's not the best picture, but it at least gives you an idea of what to look for. So here's my true solution. So my true solution is x equals 0. So you can kind of see that. Let's go trace, graph trace. So right there's my solution, x equals 0. So to get the extraneous one, I need that bottom half. So you're just going to press tab, and then you're going to type this with a negative sign in front, because that's your vertical reflection, right? That's going to turn it upside down. 2x plus 16. And there's my extraneous solution right there. See, that matches that kind of the location of it, the general kind of position. So let's trace again. Go to the left. You know what? You can also guess. So I'm going to guess 1, 2, 3, 4, 5, 6. I'm going to type in -6. Let's just guess. Oh, right. I need to switch graphs. So to switch graphs, you press up or down. Okay, so it looks like right at -6 is where that solution is. The extraneous solution. So extraneous, x equals -6. So there's your true solution and your extraneous solution. So you just really got to remember this vocab word right there. Or make an anchor chart. That'd be a good idea. Some of you need extra credit anyway. Why not? 14. Find the inverse function of f of x equals 2 to the power of x minus 9. So remember, this means switch x and y. So I've got my function. I'm just going to rewrite it. Now remember, f of x is really y. Okay, then I want to switch x and y. So I'm going to have x equals 2 to the power of y minus 9. And I need to get the y by itself again. So I can use reverse PEMDAS. Can I add or subtract anything to get the y alone? Well, yes, I can. I can add 9 to both sides. That'll cancel that out. So x plus 9, please do not say 9x. Please do not say 10x. I'm not adding 9 x's to this side. I'm just adding the number 9. I don't know what x is, so I can't combine those. They're not like terms. It's just x plus 9. equals 2 to the power of y. Multiply and divide, there's nothing. There's actually no multiplication or division in this problem at all. Unless you expand the exponent, which we're not going to do because it's a variable. Then I'm at my exponent step. So remember, when my variable is up there in the exponent, I got to use a log. So I have log base 2 of x plus 9 equals y. And then my y is by itself, and I'm done. "15, give the transformations for each function below." So remember, you got your left, right, your up, down, your stretches, your reflections. There's not a compression on here, but that's okay. So I've got left 7, down 14. You guys were pretty good at this. I think you'll be okay. And then, this, I don't think it's on the test. It's going to be a horizontal compression. Because it is inside the symbol, right? Right inside there. And then up 10. And then I have 2 vertical stretch by 2. I've got a left 5. I've got a vertical reflection, left 12. These are all lefts. So think, make sure you know what would make it go right instead of left, because these are all left. And then down 27. Number 16, solve natural log of 6x minus 2 minus the natural log of 2 equals the natural log of 8. Remember, ln of whatever is just log base e of whatever. So a lot of people get thrown off by the ln, or they call it in, or they think it's 1n. No, it's ln. It's just a log. So it's the same as every other log. So since I'm taking log minus log, I've got to use quotient rule here to combine them. So I have the natural log, so ln log base e, of, and then remember to use quotient rule, you're going to take the first one and then put it over the second argument. So first argument divided by second argument, and then equals whatever's over here, ln of 8. Now the nice thing about this particular problem is that now I've got a log with the same base, so they're both log base e. I've got 1 on each side, so I can just cancel them out. And I have 6x minus 2 over 2 equals 8. And that's just a reverse PEMDAS problem, which makes it super easy. So I do have addition and subtraction, but it's up here in the numerator, so I can't do it yet. It's kind of like as if that were in parentheses. So first I have to get rid of that 2. So I'm going to multiply both sides by 2. So 6x minus 2 equals 16. So now I'm in the parentheses, so I can add 2 to both sides. And then I have 6 times x equals 18, so just divide by 6, and then x equals 3. And you do want to double check, make sure you don't get an error message, so remember to plug that back in there. Let's actually do it. So here's what I typed in the calculator. Now you could double check and make sure that it equals that side as well, but all I'm really looking for is making sure it's not extraneous. I just don't want an error message. If you wanted to check the whole thing, then you also put in the right side. So ln of 8, and just make sure it roughly matches, which it does. Go us. So we got it. Yay. 17, find a regression equation to model this set of data. So this is that list in spreadsheets that we did last week, or 2 weeks ago, depending when you're watching this video. So I'm going to do that real quick. I've entered the data in list in spreadsheets, and again, make sure you get off that last cell after you enter the last number, and then add a page, data and statistics, place your variables. So I can see it's quadratic. It is not going to be linear. It's going to be quadratic. Did it say that? No, it didn't. But it's going to be quadratic. It's an upside down U. So menu, analyze, regression, show quadratic. Make sure you pick 4 quadratic and not 6 quartic. That's different. And then write down your equation. And sometimes you will have to scoot it over. Now this is going to be a multiple choice question, but still want to make sure you scoot it over so you see the whole number. There. There's your long equation. Yay. Okay, 18. Solve this rational equation. Now you could try graphing each side separately and solve it that way, especially if you've got Desmos. But we're going to go ahead and solve it by hand, which means I need a common denominator. So just like number 8, if you did number 8 with me, we're going to get a common denominator by multiplying by whatever the other denominator is. So I'm going to multiply this first fraction. Let me get rid of that. This first fraction I'm going to multiply by 2 over 2. Same with this one. And then this one's going to be times x minus 7 over x minus 7. So then my denominators are all the same. Well, I'm going to multiply the top. So 2 times x is 2x over 2x minus 7 equals, so 1 times x is x, 1 times negative 7 is negative 7, and then 2x minus 7, and then plus, and then 2 times 7 is 14 over 2 times x minus 7. Now, at this point, my denominators are all going to cancel out. I do want to go back and check them at the end and make sure I don't get no solution, but for now, I can ignore the denominators because they're going to cancel each other out anyway. So I have 2x equals x minus 7 plus 14. And go ahead and combine the like terms right now because they're just sitting right there. Why not? So negative 7 plus 14 is just 7. Okay, then let me rewrite what I got. Now I've got x's on both sides, so I need to cancel the x from one side. I'm going to go ahead and cancel this one here. So to cancel an x, I can subtract it. So 2x minus one of the x's is just x equals 7, so x equals 7. Now you do want to plug back in. Plug it back in. Watch what happens. So I'm just going to plug it into one side, in fact. So 7, I'll give a fraction, 7 over, and then x, we got 7 for it. So 7 minus 7. Anybody see what's going to happen right there? That's right, my denominator is going to be 0. Undefined! So this is not really a solution. I got undefined here. If I plug 7 into that denominator, the denominator is going to be 0. So this is really no solution, unfortunately. Nope. 19. We're going to solve this equation using reverse PEMDAS. So I can subtract 15. And then, again, I didn't leave myself any room. I always do that with these rational exponents. So there's nothing to multiply or divide except what's in the parentheses, so I can't get to it yet. So now I'm at my exponent step, which means I use the reciprocal. So 3 over 2, the reciprocal is 2/3. Those cancel each other out. So 8x minus 1 equals 9.22087 approximately. Then I can add 1 to both sides. So 8x equals 10.22087, and divide by 8. So I get 1.15261. Normally you want to plug it in, make sure you don't get no solution again, but this isn't gonna 8 times this and you're only subtracting 1, that's gonna be fine. Number 20, a lot like number 17, go to your list and spreadsheet page. So there's all my data in the list. Make sure you get off the last number you typed. Add a data and statistics page. Add your X and Y. And it should be quadratic. And annual menu, analyze regression. Make sure you choose quadratic and not quartic. Okay, quartic is to the 4th power. I want to the 2nd power. And then write down your equation. And there you got it. Oh, that looks really funny. That's a 5-3, by the way. If you're doing this at home and you don't have an Inspire.